Yeah, so this is the problem. A tetrahedron. An isometric projection of a rectangular prism of 60 by 80 into 20 millimeter thick, surmounting a tetrahedron of sides 45 millimeters, such that the axes of the solids are collinear. So two solids, one is a rectangular prism, another one is a tetrahedron. So their dimensions are given there. So what you're supposed to do is you have to convert the tetrahedron, the actual dimension into an isometric dimension by multiplying the actual dimension by 0.816. Okay, so I will just continue, just observe how it will goes. So now they will start 80 into 0.816, which is at an angle 120 and parallel. So this is the base of a rectangular prism, which is having a 60 by 80. Now they are taking 20. 20 is the height or the thickness, what we can call. So again, 20 should be multiplied by the 0.816, and from each corner, or you can just copy and paste or move.
Then you can replay.
So this is see they have constructed the rectangular prism, the bottom solid here. Okay, so just to draw 30-degree lines on either side. Okay, take a 60 millimeter length or a 60 millimeter isometric dimension in the right side, and the exactly 80 millimeter isometric dimension in the perpendicular direction. So this is how we will going to get the rectangular prism. Okay, so now they will go into construct a tetrahedron. A tetrahedron should be constructed and it should be placed over the exactly at the center of the rectangular prism. So how they will going to do, we will going to just see.
Okay. Only okay. Let them speak. Not a problem. Just I will take your okay. You will switch off your phone. Mic. Okay. Now, let's follow. Only audio, video, technical everything is working properly. I take no assistance. So I will not going to share that on screen. You see that that's the major. Clear. Clear now you speak. Seconds.
See, they are constructing an orthographic projection of a tetrahedron. So tetrahedron is basically a solid made with 4 equilateral triangular faces.
Okay. Now, dear students, now it is a revision. Syllabus have completed yesterday only. Now, for the third test, module 5 is the portion. So today, this what you can do is just some of the scales shaking. These you can sketches you can practice. So take a paper and pen and just to practice these robot configuration.
Yeah, this is the front view of a tetrahedron.
Classification of robots based on configuration. There are 4 configurations of the partition coordinate configuration, cylindrical coordinate, spherical coordinate, triangle configuration. So among these 4 configurations, 2 or 1 definitely come from the examination, not from the test. So therefore, you just practice these diagrams to give overall summary about these, what are these configuration is. Say robot has to move vertical direction, horizontal direction, sometimes it has to rotate. Depending on the application, different types of movement.
Yeah, what they're doing here is,
basically they're dividing
see, the top view of this tetrahedron will be enclosed with a box. Okay, so when you enclose this with a box, so the box size will become 38.97 into 45. Okay, so enclosing the top view of a tetrahedron with a box by box, and that box, the size will be 38.7 in the x direction, and in the y direction it will be 45 millimeter. Now first you have to construct that box. Okay, under that, on that box you have to construct what is the base of a tetrahedron. So this is what they have done. So if you want, you can just go back and will see.
Yeah. Okay. Is it okay? What
yeah, after constructing, see.
So what did I say?
So what they are doing is 38.97. So this is the dimension. 38.97 is multiplied by 8.16. So that 1.8 they have drawn this line. And the other side of the box, what you are enclosing, it will be 45 millimeters. So look at there, 45. 45 into 0.816. So like that, first you have to enclose the box. So you have to construct the box with that dimension. See, this is how you will go into, first you will go into construct the box which encloses the top view of a tetrahedron. Afterwards, what they are doing, you see, from there to the midpoint. So you are joining with the line. So this will constitute the base of the tetrahedron. Now you are taking the center line. See, center, what is this height here? 36.74 multiplied by 0.816. See, they have to do that. And then they have to join each point. 1, 2, yeah. And the third one, yes. Yeah. So now you have to get the center of this rectangular prism. Okay. So on that rectangular prism, you are placing this tetrahedron. So please understand how to construct the isometric drawing or isometric projection of the individual solids. So placing one over the other after constructing the isometric projection of individual drawings, then you will going to place one over the other. Okay. Yeah, so this is the completion of the isometric projection of a combination of two solids. One is a rectangular prism at the bottom. Second one is the tetrahedron, which is placed exactly at the center of the top, across this top of the surface of the rectangular prism. Okay, so I will just brief once again how we will going to do. So here we have two solids. So bottom solid is a rectangular prism of a size 60 by 80 into 20, where 60 is the length, where 80 is the breadth, 20 is the thickness, and it carries, or on over which it there is a tetrahedron of 45 millimeter side, such that the axis of the solids are collinear. So now, and also at least one of the edges of both the solids and are parallel to each other. So what we are doing here is, so we are just constructing, first you draw the horizontal line. So draw the two lines on either side for 30 degrees. Okay, so start constructing the rectangular prism first. First, you construct the base of the rectangular prism for the size of 60 by 80. Okay, so 60 should be in this direction and breadth should be 80 millimeters. And then after constructing the base, the bottom surface, then you have to get the top surface. So top surface is at a length or at the distance of 20 millimeter, because 20 millimeter thickness they have given. So 20 millimeter, you can draw that and just complete the rectangular prism. Now, on this center or the top surface of the rectangular prism, we had to place a tetrahedron. So to construct an isometric projection of a tetrahedron, first you have to draw the orthographic projection of a tetrahedron. In the sense, first you have to get the top and front views. So, what we discussed in the projection of solids, so draw the tetrahedron. The top view of a tetrahedron will be an equilateral triangular. Okay, so just draw the equilateral triangle of 45 millimeter side. Okay, so then join their corners, draw the medians of a triangle such that that will be shown as in the four top, what we call it as the triangular surfaces, and measure this perpendicular, this distance. This distance is very much required for us, and then project it for the front view. So draw the projector lines to the XY line, and from the power point where you will get a corner, of course the axis length will be, so just to project the, draw the axis to a certain length, and from the corner point take a compass and measure the distance as a 45 millimeter side. From there you cut the axis, then from there you join those two. So this is the construction of a top and front views of a tetrahedron. So the height, the vertical height of a tetrahedron will be 36.74, and this distance is 38.97. After constructing, what you have to do is, so we have to get the isometric projection of this tetrahedron. So construct it separately, and then afterwards you can just flip it over the top surface of the rectangular prism. Okay. So for constructing an isometric projection of a tetrahedron, so first what you have to do is you enclose the top view of the tetrahedron in a box. So once you enclose it, so what happens? The size of the box will become 45 by 38.97. So first you construct that box in the isometric projection, that is easy, and then you can transfer the corresponding points to get the tetrahedron. So what we have to do is, first you will just draw the box of the size 45 by 38.97. So once you get that, so then, so this is what we are getting. See how they are doing. They are constructing the box first. See, what they're doing is they are constructing the isometric projection of a tetrahedron separately, and after constructing, they're just keeping directly over the top surface of the rectangular prism. This is the completion of the isometric drawing of a two solids. Okay. Understood, my dear students? Any clarification? Ayush, got it?
Yes, sir.
Okay. So next I will go for the next problem now.
Understood as is not showing the arrow mark is important. I hope all are practicing this one. So I'm making you to
Just a minute.
learn, practice this diagram now itself. Make realization. Don't simply see and sit. It will be waste of your time. Therefore, take a paper and pen. Practice this figure. Syllabus is completed. Syllabus is completed.
Yeah.
Some of the
Start this problem now.
Topics I'll be doing the revision and let me not waste your time to make utilize of this time. Take a paper and a pen, you write this figure. This is you are practicing this for main examination. Now it's this will not be your waste of time.
Okay. Yeah. We'll start doing this problem. So the problem is the frustum of a square pyramid of sides 40 millimeter and height 60 millimeter rests on the center of a top of a square block of side 60 millimeter and height 20 millimeter. The base edges of the pyramid are parallel to the top edges of the square block. Draw the isometric projection of the combination of solids. See here the word frustum. So frustum means, so when we just have solid, just generally we get a frustum and a truncated part in the case of a pyramid and a cone. So frustum means, so by passing a cutting plane exactly perpendicular to the axis of the solid, the remaining portion of the solid we call it as the frustum. Frustum means, so when you just take a solid and when you cut it, such that the cutting plane will passes exactly perpendicular to the axis of the solid, then that will constitute the remaining part of the solid. We call it as the frustum of a solid. So when you say a pyramid, a square-based pyramid, so when you remove, if you take the pass a cutting plane from the apex of the solid to a certain length along the axis, and the cutting plane is perpendicular to the axis of the pyramid, then if you remove the top surface, the remaining portion of the solid will what we call it as the frustum of a pyramid. So in the case of a square-based pyramid, the top surface frustum of a square-based pyramid, the top surface is also a square and bottom is also a square. So this is what one problem we are having here. The frustum of a square pyramid of sides 40 millimeter and height 60 millimeter rests on the center of the top of a square block of sides 60 and 40. The base edges of the pyramid are parallel to the top edges of the square block. Draw the isometric projection of the combination of this. So we will going to just look at this. This is a very simple problem, but also very important problem from the examination point of view. Just observe this, how it goes.
This kind of rope has a vertical column with a rope arm attached to a side which can move up and down the column. Simultaneously, the arm can move radially with respect to the column. The overall volume or work envelope is a portion of the cylinder. Usually, a full 360-degree rotation is not permitted due to restrictions
Just
imposed by
observe.
hydraulic, electrical, or pneumatic connections.
See, we are placing a frustum of a square-based pyramid on the center of the top of a square block. So bottom surface will be a square block, okay, and top surface will be the frustum of a pyramid.
That is this diagram.
See, what they're doing here is, just observe. So first they are constructing a square block of a 60 millimeter, okay, height 20 millimeter. So square block has been constructed here. Now they had to construct a frustum of a square base pyramid. So here we are having two square faces. One is having top edges. I think one dimension is missing actually here. The top surface should be of 20 millimeter. I think they have forgotten to give this. Okay, the top square looks is a 20 millimeter. I think the data is missing in this problem. So the base will be 40 millimeter and height is 60 millimeter. But that, because once you say it is a frustum of a pyramid, so square, the top surface is also a square. So that square side is given as 20 millimeter. The data is missing in this. So this is 20 millimeter side and the bottom will be 40 millimeter side. So please observe how they will going to construct these two squares and how they will going to join. See, this is what they are constructing. The base of it, it is the bottom of it, which is a square block of 60 millimeter side.
Yeah, Jay. So, on behalf of other students, they're communicating the ratings showing important anomaly terms. Well, then. I have noted down these arrow marks. The important have shown. Okay, thank you. Continue. You will read.
Yeah. See, what they have done here is they have copied the 60 millimeter square block again, two square, because we have 40 millimeter square, one square, which is at the base of the pyramid, and another one is a 20 millimeter square at the top surface of the prism. So therefore, what they have done here is they have copied the 60 millimeter square two 60 millimeters, right? And they have done scale it down. So one is 40 by 60, so you're going to get that square, and another one is 20 by 60. So because 60 square should be converted into 20 millimeters. So this is what they have done. Okay, so now you just observe what they're doing is they are marking the center of across the top surface of the square block. Now they will going to keep all those things. Okay.
You will end the class now. All of you send your USN number in the chat. After three digits of USN number, you send by chat. Is it okay clear? Yeah, Jane. We are Jane. Online. Worshale Pandere Krishna. We are Jane. So,
yeah. So this is how you will go to construct a frustum of a square-based pyramid placed over the square block. Most important problem from the examination point of view. Okay, so please practice this. Very simple. You can do it very easily in your sketch sheets also, and you can do very easily in your drafting in your solid edge also. Okay, the same procedure you can follow in your sketch sheets, but you cannot do it separately. Directly, you can construct all these things in your sketch sheets. Okay, so we'll have next problem now.
Yeah.
So the problem is a regular pentagonal base pyramid prism of edge 30 millimeter and axis 60 millimeter is mounted centrally over a cylindrical block of 80 millimeter diameter and 25 millimeter thick. Draw the isometric projection of the combined solids. So here we have a pentagonal prism. So prism having a pentagonal base which is placed over centrally over the cylindrical block. So cylinder means it will having the surface of revolution formed by the rectangle. Okay, so it will have both the top and the bottom. It will have a circular faces. Okay, so whenever you are constructing a cylinder, the top surface or the bottom surface which will be having a circular that needs to be constructed as an isocircle in our isometric drawing, isometric projection. Okay, so they will going to explain it now how easily you can do it on your sketch sheets as well as on your system. Okay, so we have two solids. One is a cylinder, another one is a pentagonal prism. So pentagonal prism is placed over centrally over a cylindrical block. So here the bottom solid will be a cylindrical block and top solid will be a pentagonal prism. Please observe the procedure how they will going to do. Okay, so then same thing you can implement in your sketch sheets as well as in your drafting. See what they're doing there. First, they are to construct a cylindrical block. So cylindrical block construction is top view of a cylinder will be a circle of 80 millimeter diameter. Am I right? So we just go back. Just a minute. Yeah. So what they are doing is, first they are enclosing that circle of a cylinder in a box. So when you enclose it a box, the size of the blocks will be equal to the diameter of the circle. So here 80 millimeter diameter means you are going to get a 80 millimeter square. So first that square has to be constructed, and using the 4-center method you have to construct an isocircle. So I'm talking about that is the base. First you are starting with the base, and similarly you will be knowing what is the height of a cylinder. It is given as 25 millimeter, and exactly at the 25 millimeter you have to construct another one isocircle. So, and then there you have to draw the tangent to the two isocircle that will constitutes the cylinder in an isometric projection. Okay, so first thing is you enclose the circle of a cylinder with a box. Okay, so this is what they are doing here. Now you can see here. So 80 into 0.816. So this is what they have done. Yeah. Now you see how they construct the isocircle by 4-center method. First join their corners with a thin line. Locate the midpoints. Yeah. Yeah. So this is how we construct an isocircle by using a 4-center method. Okay. So the base of the cylinder is a circle, and it looks like an isocircle in the isometric projection. So this is how they have constructed an isocircle at the base of the cylinder. Now we have a cylinder height or a thickness of 25 millimeters. So now how they will going to do, the same isocircle has to be copied and projected over there, and then you have to draw the tangent to these two isocircle, and that will forms a cylinder in an isometric projection. Just observe this.
Module. Gel.
See, this is how you are going to just copy it down in your solid edge. But the same thing does not happen when you are doing it in a manually, in a sketch sheets. In the manually, what you have to do, again, you have to project it for 20 millimeters above, 25 millimeters above this. You have to construct another one circle box over there, and then again you have to construct the isocircle over there. Okay, so this is how we are going to do this. So you are drawing the tangent to the isocircles here. Now, once you complete the cylinder, the next thing is we have to construct an pentagonal prism. So for pentagonal prism, how they are doing, just observe here. Yeah. So now the base of the prism is a pentagon. So side is given as 25 millimeter side, and it is a 5 sides pentagon. So here, so first construct the top view of the pentagon. Yeah, so this is how we are going to construct the base of the prism, which is a pentagon. Okay, so again, pentagon should be enclosed in a box, and that box has to be constructed first for a length of 46.17 by 48.54. So then you have to correspondingly you have to transfer all the points over there, and you have to join with a pentagon. Okay, straight line to get a pentagon. Yeah. Just explain this. See. What they're doing is they're constructing a pentagonal prism over there. Okay, so again they are copying the same pentagon to a height of how much the height of a pentagon is 60 millimeter height, and they are just drawing the rectangular faces over here. Now they will going to keep all this pentagonal prism exactly at the center of the top surface of the cylinder. So the edges which are not visible, you can just take it out, you can trim it off. Yeah. Yeah. So this is what the very important problem again from the examination point of view, a pentagonal prism placing over a cylindrical block. Okay, so please practice this in your sketchbooks as well as in your the solid software if you are having. Okay, so then I will take for the next problem now. This is similar, not required this one. This is a very important problem. Just observe here. Yeah, a sphere of 30 millimeter diameter is placed over the frustum of a hexagonal pyramid base. Okay. Yeah. The problem is a sphere of diameter 30 millimeter rests on the frustum of a hexagonal pyramid base 30 millimeter, top face 18 millimeter side and a height 50 millimeter such that their axis coincides. Draw the isometric projection of the combination of solids. So here again the frustum of a hexagonal pyramid. So hexagonal pyramid frustum is there, that is forms the bottom solid over which the sphere of diameter 30 millimeter is being placed. Okay, so the hexagonal pyramid base of 30 millimeter, top face which is also hexagon of 18 millimeter and height of 15 millimeters. Okay, now let us just observe how they will going to construct this in your drawing. So look at that. Observe carefully. If you have any clarification, you can stop. Okay, so what they are doing here is they are enclosing a base of a hexagonal pyramid with a box, and first they are constructing the box. Same thing, same procedure. Whenever you get any pentagon or a hexagon, whatever it might be, so except square, so you just enclose that with a box and first construct that box. And later part, you can just transfer those points to get the hexagon shape. Okay. Now the top face of the pyramid is 18 millimeter. So they have just scaled down to 18 by 30 and they are placing that the top face of the hexagonal pyramid. Now they are placing the sphere at the center of the top of the frustum of a hexagonal based pyramid. So when you are doing a sphere, be careful. So the center height should be isometric height, and the radius or the diameter of the sphere should be the actual diameter. Okay. So when you're taking the center height, so when you're measuring the center height from the top surface of any solid, so measure with the isometric height. So if it is the radius is around 50 millimeters, so multiply that 50 by 25 by 0.816 and then measure, which mark the center point. And with that as a center and radius equal to the actual radius, then you draw the circle. So that will forms the sphere for us. Okay. So this is only a pentagonal pyramid. This is only a single solid. So now they have constructed the base of the pyramid, which is pentagon. total height is given as 60 millimeter, that is converted into an isometric dimension now by just multiplying by 0.816. Now they are joining with the slant edges. So this is this isometric projection of a pentagonal pyramid. So the next problem is, draw the isometric projection of a hexagonal prism of side base 40 millimeter and height 60 millimeter with a right circular cone of 40 millimeter as diameter and altitude 50 millimeter resting on the top such that the axis of both the collinear. So we are having the bottom as a hexagonal prism and at the top we are having a cone. Okay. So please observe how it will be constructed. So bottom hexagonal prism. See, now we are constructing a hexagonal prism. So now they are constructing the base of the cone, which is a circle of 40 millimeter side, and they are constructing it separately. So base of the cone looks like an isocircle in the isometric projection. So now they are placing that over the center of the hexagonal prism. Okay.